So today we will continue the problem which we were solving on practice. So this particular problem is an example. If in case in a question, if he asks to calculate P average, minimum pressure and maximum pressure to operate a clutch. If he asks in the problem, it might be in the problem, he might ask only P minimum or only P maximum or P average, depends upon the question. So in this particular example of a numerical, we'll just try to understand how to calculate all this. Okay, let's go to the given data now. Determine the average, minimum and maximum pressure in a plate clutch subjected to an axial load of 6 kilonewton. So axial load is how much? 6 kilonewton. Axial load is nothing but FA, which is given as 6 kilonewton. The inside radius of contact surface is 60 mm. Alright. Radius here is given, which is 60 mm, and the outside radius or not is 100 mm. So you have to assume uniform wear to calculate all this. Okay, so to find okay, shall we go with the solution? Yeah. Shall we start the solution? Are you guys ready? Okay. So the average pressure is calculated by using a formula. P average is equal to FA divided by pi times of R naught square minus RA square. And this particular formula is not available in the data handbook. You have to remember this, and that is the reason I have written in color. Okay, you have to remember this. Okay. This is average is given at a handbook. Okay. So now I guess everything you know. Please do substitute and give you the values of average pressure. Okay. FA is 6 into 10 to the power of 3 divided by pi times of R naught is 100 whole square minus R is 60 square. So what is the value of P average? So whatever answer you get, you directly get it in megapascal because it is Newton's per mm square. Oh, excellent. 0.2984 is the value of average pressure. Okay. So the only thing in this new thing is you have to remember the formula for the average pressure. That is why I have highlighted in red in color. So and I have even written remember. So please do write the same thing in your notes as well. Okay. Now, so you can find this equation in your data handbook, which says axial pressure of force is given by FA, that is equal to pi by 2 d, sorry, it's P and D. Just check this equation, man. D naught minus of di. I hope it is d, which is taken from, I'll give you the equation number though. It is 13.9 d base number 258. This is the equation. Fine. So I hope there is another parameter in between. According to my knowledge, I'm not sure. There must be some parameter in between. Just check this equation, 13.9d, page number 258. I guess it is P. Pressure has to be multiplied. Just check.
P max.
Yes?
P max.
Okay, P max is there. So pressure has to be multiplied over there. So there is a P in between. Okay. And this particular expression is used to calculate the axial force wherever is required. Suppose if your clutch plate is something like this, okay, so this is your clutch plate. So if there's spin like this, so generally what happens, I'll just clear the concepts here. Okay, so this is a lining, okay, and this is Ri, okay, or not, right? So generally, the pressure intensity will be minimum at the outer radius. So here, you can find P minimum there. Where? In or not? In the outside radius. In the inside radius, the pressure will be maximum. So here, you can find P max. Suppose, if you want a pressure anywhere in between, okay, at a distance r, from the center. So then you can use this particular formula. Okay. So that is how P max into di. Yeah. Okay. So generally take this statement. Generally, pressure will be maximum at the inner radius, and the pressure will be minimum at the outer radius, because we'll engage the clutch from the center towards the outer side. So keep that concepts alive. We'll come to that. Okay, we'll be using this particular formula now to calculate our P minimum and P max. Okay, now since all these stuff diameters, so I just convert it into radius. Okay, so how to convert it? It is pi by 2 cross P cross D in terms of R is R by 2. Sorry, 2R, right? 2R into 2 or not minus 2Ri. Am I right? Am I right? So what happens there next? 2 and 2 goes in. 2 I will take it common from. Okay, 2 I will take common from here. So what happens is I would get 2 times of pi into r naught minus of Ra into P. So the axial force is given as such. So I'll be taking this as equation number 1. So am I correct till now? Any mathematical errors? Is that correct? Just need confirmation from your guys. Okay. Now, I told you just now that two cases are there. Just write this. I would write it in red color because since this is a new concept, the pressure intensity, is minimum at where? Inner or outer? Pressure intensity is minimum at where? Inner or outer? I told you just now. Where the pressure intensity is minimum?
Outer.
Outer. So just write outer there. Okay. So outer radius. Okay. Therefore, I can say when R equal to R naught, it implies P equal to P minimum. Okay. So the formula would be changed as such now. Fa is equals to 2 pi R when R is equal to R naught. Okay. And P will be nothing but P minimum. Please do substitute all the things and get the value. So it is 6 into 10 to the power of 3 is equals to 2 pi. R naught value is so into 100 minus of Ri is 60 into P minimum. So from this, can I have the value of P minimum? Whatever you directly in megapascal. Because you are substituting in mm there. Newton per mm square will get that. Okay, so I already have an answer. So 0.2387. 0.2387. Now, similarly, pressure intensity is maximum at the inner. I have told you the clutching action happens from inner to outer. First, ಹೊರಗಡೆ ಒತ್ತಿ ತದನಂತರ ಹೊರಗಡೆ ಹೋಗ್ತಾ. That is how the clutching action happens. Always remember that. Okay. It is maximum. P max. Substitute all the values and get me the value of P maximum. 6 into 10 to the power of 3, 2 pi into Ri is 60 into 100 minus of 60 into P max. So from this, Pmax is equal to okay, 0.3978, 0.3978. So there ends your problem. Okay. Any doubts in this? Any doubts in this particular problem? Guys, any doubts? Please let me know. Okay. So we will take up the next problem. Shift it there. So please copy this problem. We'll start in a couple of minutes. Shall we start, guys? Shall we start? Okay. Let us see what it is, what we have in this problem. Given data. The multi-disc clutch of steel on bronze category. That means two different plates are used. First, the force will be applied on bronze, next on steel. These to transmit 4 kilowatts of power. So he has given us the value of power that is need to be transmitted. It is 4 kilowatts at speed of 750 RPM. Okay. Now, the inner diameter of contact is 80 mm. So DI value is specified, which is 80 mm. Next, and the outer diameter of contact is 40 mm. That means D naught is how much? D naught is 140 mm. Okay. The clutch operates in an oil wet. That means it is a hydrodynamic say. So it operates in an oil with the coefficient of friction mu is equal to 0.1. So mu is 0.1 here. The average allowable maximum pressure is how much? P is equals to 0.35 megapascal. Okay. Next, assume uniform wear theory, and this one thing you have to remember: unless and until he has specified in the problem to use uniform pressure theory, you must always use uniform wear theory. Okay. Unless he specifies. So all the design engineers will maximum use uniform wear theory. Uniform pressure theory we will not at all use unless he has specified in the problem. Deliberately, if he specifies in the problem to use uniform pressure theory, then only you use uniform pressure theory. Or else you have to use uniform wear theory. Is that clear? That particular point I forgot to say. And determine what we have to find in this problem. So to find number one, number of steel and bronze discs. So I guess he is asking us the value of n dash, which is nothing but n1 plus n2 minus 1. So he is asking us the value of n1 plus n2. Okay. So n1 plus n2 is being questioned. Very good. Next, axial force required. That means FA is being axial force is asked. So this is the problem for you. Let us move on with the solution. So first thing you have to make a clarity upon is we know that n dash is equals to n1 plus n2 minus 1. So from this, n1 plus n2 is equal to n dash plus 1. Okay. I will be taking this as equation 1 I will be using further. Okay. Next, torque is given as what? Half mu Fa dm n dash. Okay. So if you if you feel difficult to remember it, you can take it from equation number 13.9e, page number 258. Okay. So from this, let's calculate one by one. We know that power is equals to 2 pi nt by 60. So power is given as 4 into 10 to the power of 3 kilowatts. That is 2 pi into n is given as 750 rpm into torque divided by 60. So from this, I'll be getting the value of torque in Newton meters, which I am supposed to convert in Newton mm for my substitution. Yes, what is the value of torque? Yes, what is the value of torque and mean diameter? How to change this? Okay, so torque is 50.92, 50.92 Newton meters. So in Newton mm, it would be 50.92 into 10 to the power of 3 in Newton mm. So now, can I have the value of mean diameter? After that, you start calculating Fe, which is pi by 2 P di into d naught minus of di, which is taken from 13.9 D, page number 258. The beauty of the clutches is all the formulas will be having only one. 110. Okay. Now start to calculate your Fe. Pi by 2. No much tables involved in the clutches. Simple calculations. Pi by 2. P value is to put in the 0.035. Cross di is 80 into d naught is 140 minus of 8. So from this, what is the value of F8? So answer whatever you get, that would be in newtons. Okay, 2638.94, 2638.94. The same thing I will enter here. Now substitute all the things and calculate n dash, the torque equation, into mean diameter 110 cross n dash. So from this, okay, 3.5 approx. So shall I round this to 4? Okay, accepted by all of you. Rounding off to 4. Because since it is a number, I cannot make half of a plate. Is that right? Yeah. Now this, remember, this is not the value required. What we require is n1 plus n2. So from 1, n1 plus n2 is equals to n dash plus 1. Correct? So it is 4 plus 1. From this, number of steel and bronze plates which is required is 5. See, for you, the design has been very much simplified. It is at a very basic level. Okay. Even I have referred all of your question papers. Nowhere it is asked how much bronze plates you require, how much steel plates is required. Cumulatively, they will ask. That means the cumulative value of n1 plus n2 will be asked always. So if you go in depth of the designs of clutches, you'll be having plate-wise designs. What should be the dimensions for each and every plate? That is not there for you. So keep it. It has been simple. Okay. Now n1 plus n2 is done. I guess now you can calculate the value of Fe second to find axial force. So Fa is equal to. So you can use the torque equation for that. So torque is equal to half mu Fa dm n dash. Now substitute all the things, whatever you know. That's 50.92 into 10 to the power of 3. That is equals to half cross mu value is 0.1 cross Fa, that is required to be found out, into 100, 110, and do not substitute 5 here. It is 4. It is the value of n dash that you have to substitute. Okay. So from this, the value of Fa is how much? And this was asked in one of your previous year's question papers, guys. 2314. it is 2314 0.5 newtons. Similar problem, exactly similar to the previous one, which was, is this particular question is taken from your previous year question paper. Copy this, we will solve this and end the class. Okay. Okay, shall we start solving it? Yes? Shall we? Okay. So the power which is given in this problem is 8 kilowatts. Speed 1440 RPM. DI 80 mm. D naught 140 mm. MIF 0.1. Pressure intensity 0.0, not 0, 0.35 megapascal. So what is being asked? To find one thing, number of plates, N1 plus N2 is being questioned. Second one, axial force is questioned. And third one, maximum pressure, that is Pmax, is being questioned. Let us jump into the solution quickly. So first, take the torque equation. So torque is equal to half times of μ cross Fe cross Dm cross n dash, and this equation is taken from 13.9d, page number 258. Next, calculate the torque now. So power is equals to 2 pi nt by 60. Substitute, it is 8 kilowatts. 2 pi running at 14040 RPM into torque divided by 60. So from this, the value of torque, whatever you get, if you get it in Newton meters, keep the value in Newton mm as well. Later, calculate the value of dm, d naught plus di divided by 2. So it is d naught is 140 plus di is 80 divided by 2. So the value of dm in mm. Next, calculate the value of Fa. It is pi by 2 p di into d naught minus of di. So that is equal to pi by 2 cross 0.35 cross di, value is 80 into 140 minus of 80. Whatever you get, the value of Fe. So this would be in newtons. Can I have all these values? Torque, dm and Fe. Okay, 53.05. So 53.05 in Newton meters. In Newton mm, it would be 53.05 cross 10 to the power of 3. dm is 110. Okay, same. Previous problem is the same value or what? It's different. Okay. Now calculate Fe. 2638. 2638. 9. Good. Very good. Now substitute all the values in the torque equation. You will get 53.05 into 10 to the power of 3. That is equal to half times of mu value is 0.1. Fa value is 2638. DM value is 110. cross n dash. So from this, we will get the value of n dash. Please confirm the values given by Nandan. Okay, I'm just taking that values directly. I've got 3.65. Same thing, 3.65. So approximately, I will take it as 4. We know that. What we know? N1 plus N2 minus 1 is nothing but N dash. So from this, N1 plus N2 is equals to N dash plus 1. N dash is 4 plus 1. Therefore, N1 plus N2, number of plates, would be 5. So once I get the value, again use the torque equation to calculate FA. Okay. To find FA, can use the torque equation that says P is equal to half mu FA dm n dash. So substitute all the values. 53.05 into 10 to the power of 3 half 0.1 FA 110 cross 5. From this, what is the value of FA you are going to get in 2411.36. Now, in order to calculate Pmax, we have already learned the formula. Third one, to calculate Pmax, I would take that particular formula from the previous problem, okay, which is this. So here it is in terms of diameters. So I will take in terms of diameters directly. So when B value is equal to BI, P will be equal to Pmax. The pressure is maximum at the inner side. Same thing I will be using here. Okay, now from this, it is 2411.36. That is equals to pi by 2 cross P value is 4. No. P value we have to calculate. Okay. So before to that, I will be just writing the equation so that you will not get confused. So yes, A is equals to pi by 2 D into D naught minus of DI. So when D is equal to DI, P will be turning into P max. Now we substitute it. So it is 2411.36 is equals to pi by 2 cross what is the value of DI? 80. D naught is 140, I guess. 140 minus 80 into Pmax. So from this, I will be having the value of Pmax in megapascal directly. Very good. So it is 0. Very good, guys. It is 0.3198 megapascals. So there ends your particular problem. Now, two things to discuss at the class end. Number one, so everyone in this class has to make